Lesson 7.5, we're rationalizing denominators still. So this is our second lesson, and we're going to rationalize denominators that have cubed roots in it this time. So I have a couple examples for you. First of all, if you don't have the list of perfect cubes out in front of you, you might want to get that list written down. I have it here for you the perfect cubes are 1, 8, 27, 64, 125, 216. Those are the first 6 perfect cubes. Having that list out handy will help you as you're working along here. So here's our first example. The cube root of 2/9. Cube root of 2/9. So how do I deal with this? Well, I start first by using my quotient rule. And I'm going to break this apart into the cube root of 2 over the cube root of 9. Now I want to rationalize my denominator. Broken it apart, each part, numerator and denominator, separate. I'm going to look underneath here. I have the cube root of 9. In order to rationalize this, I have to have a perfect cube inside the radical sign to get rid of my radical as a denominator. So I want to look at my perfect cube list, and I ask myself, can I take 9 times a number and get one of these perfect cubes as an answer? And it happens to be 27, because I can do 9 times 3 to get to 27. So how do I deal with that? All right, I'm going to take it times, and I'm going to put a fraction bar. And I'm going to take the cube root of 9 times the cube root of 3, because I know 9 times 3 will give me 27, and 27 is a perfect cube. If I multiply the denominator by the cube root of 3, I have to multiply the numerator by the cube root of 3. Because now this fraction here is a value of 1. Isn't changing the value of the fraction, just changing the numbers. So I'm left with the cube root of 6 over the cube root of 27. So cube root of 6 over the cube root of 27. I know that the cube root of 27 is 3. So I will then write the fraction bar. I'm going to put 3 as my denominator, and I will keep the cube root of 6 on the numerator because 6 is not a perfect cube. And at this point, I have now rationalized that. I know I'm dealing with thirds. So that's how all the further you need to go with a problem like this. Let's look at our next one. I have the cube root of 3x over the cube root of 4y to the 4th. All right, so we have a variable to deal with and we have a number to deal with. So what will we do? Let's figure this out. Break it apart mentally. I'll break the denominator apart mentally into 2 pieces. I got to find a perfect cube for 4. I got to find a perfect cube for y to the 4th. So let's take a look. What can I multiply 4 by to get one of these perfect cubes up here? And the perfect cube I see that I'm after is going to be 8. So I will take 4 times 2. So I know I'm going to have to multiply this in by the cube root of 2 to start with, but I'm not done because I got to figure out what to do with my variable. So I'm going to put a cube root of 2. That's the number part. Now I got to figure out how can I deal with y to the 4th power. Well, let's see. I know from my past experiences with dealing with cube roots that if I can get this exponent, the 4, if I can get that to be a multiple of 3, because then if I can do 6 divided by 3, that's going to give me 2. So I'm going to actually then, how many y's do I then need to get to 6 here? I need 2 more. So this is going to be y squared inside here. So I'm looking for multiples of 3 for an exponent. Well, this is above 3, so the next one in line is 6. So then if I take and I put y squared, then I'm multiplying by to rationalize this denominator. And then on the top, I'm going to do times the cube root of 2y squared also. Okay, so next step. And if this doesn't make sense, come back again and talk to me. Again, the number part, look for your perfect cube list. What can I multiply the number by to get a perfect cube? And then I want to look at my variable, and I want to make sure that my exponent then is a multiple of the root that I'm after. So I'm after multiples of 3 here. So now I'm going to I think of 4, well 5, and then 6. So now I have to multiply y to the 4th times something that will then get me y to the 6th. So that's y squared, because 4 plus 2 is going to give me 6. So how do I do this now? On the top, I have the cube root. And I'm going to multiply those two numbers together. 3 times 2 is 6. I have a plain x, so I write the x on the inside. And then I have y squared. Put my fraction bar. Multiply underneath here. The cube root of 4 times 2 is 8. Y to the 4th times y squared. Add my exponents. 4 plus 2 gives me 6. So then I have 8y to the 6th inside my root symbol. How do I deal with this now? The top. There are no perfect cubes for factors in there, so I get to just copy that. I get 6x y squared all over, and that's inside my cube root symbol. And then the cube root of 8 is 2, and the cube root of y to the 6th. Well, mentally I can use a pattern, a shortcut. Is 6 divided by 3 is 2, so it's y squared. And I'm done with that. Now I have a rationalized denominator. Even though the top has a cube in it, I want my bottom, my denominator, to be rationalized, and that's what I have now. So what I want you to do for assignment, an assignment is real short. It's page 448, and there's just 6 problems to do. Page 448 with 6 problems to do. Let me know how I can help you with anything.